PM structural parts, or also people say press and cinder parts, they are net shape parts in large volumes and having high precision and high complexity. So they are beating in the price performance competition other metal forming technologies. And so in detail, there are other arguments. There's a very simple one. As PM parts are not fully dense, you could turn this around and say they are 10% lighter. So people pay a hell of a lot of money to have efforts to bring weight down. Here they get it more or less for free added. Then the whole PM process is a kind of green process, because 90% of the iron powders are recycling material of iron scrap. And then you also have the flexibility of tailoring the alloy to a certain property, even that far that you can combine in one tool set different powders, so you may have a certain magnetic property on one side of the part or a wear resistance part on the other. And then also you have the flexibility to take, instead of iron, aluminum or brass or bronze, copper-based materials. So this is a flexibility, a freedom. Rapid solidified powders give total impossible alloy compositions, and the 3D features of press tool making is making impossible to make at reasonable cost shapes of components. Yeah, call it the natural market of PM structural parts today is mobility. That means 90%, 80 to 90%, depends on the company, are making parts for automotive, two-wheelers, trucks. You could include bicycle. And this is the natural market. And in the old industry countries or regions, let's say North America, Europe, there is a saturation of these markets, but it's still a very strong contribution of PM to these industries. You have in the short and midterm the growth in the emerging areas like China, India, Brazil, South America. And there is the short midterm growth. If we look at the new products, that's an interesting question, because there is a kind of pair of scissors, because there's a downsizing trend of engines, which means less parts needed. One cylinder is one conrod, is one piston, is a piston ring, is a valve seat or 4 valve seats. So you will lose classical parts. But these new engines, combustion engines, are improved by very many sophisticated tricks. Variable valve timing, stop-start mechanisms, the electric power steering, electrification of pumps in general. And this means many and maybe more challenging parts to be produced. So probably there is a compensation of losses on one side, but there is at least higher profitable or more challenging parts to become the future. If we look on a more larger outlook, a more wider outlook, that's an interesting question. How can PM, also structural parts, contribute to the energy industry? We will have energy generation and energy storage. And here I'm talking mobile and stationary. And so you have chromium interconnect plates made by structural part press and sinter process. There are components which, functional materials being converted to components which are in the storage of hydrogen and in the combustion of hydrogen combustion engines. So this is where the material, the impossible materials I was referencing first to, and new materials are the target.